Hello everyone. Today we are going to see the second lecture in trigonometrical leveling. In the first lecture, I covered the topic base of the object accessible. Today we are going to see the base of the object inaccessible. Base of the object inaccessible means that we cannot go to the base and take the measurements. The base may be very far away or it is hidden due to the obstructions. In the base of the object accessible method, there was only one station, but in the base of the object inaccessible method, there will be two stations. The base of the object accessible method has two subdivisions, single plane method and double plane method. The single plane method falls into the following four cases. Instrument axes are at the same level. Instrument axis at the station nearer to the object is lower. Instrument axis at the station nearer to the object is higher. Instrument axes are at very different levels. Today we are going to see the first case. Instrument axes are at the same level. Let us assume that this object is a tower, and let us assume that we cannot go to the base of the tower due to the obstruction or it is very far away. Let us keep Q as the top of the tower. We need to find the reduced level of the top of the tower. This is the ground from where we are going to take the readings. In the ground, let us fix a point. Let us keep the point as P, and in the point P, we have to install a theodolite. P dash is the vertical projection of the point P in the theodolite towards the horizontal axis of the telescope in the theodolite. We have to make a horizontal projection like this. We need to make a vertical projection from Q. Let us keep this point as Q dash. And let us keep this height QQ dash as h. Let us keep the horizontal distance between P and Q as capital D. From the station P, we have to focus the top of the tower, that is Q, and take the reading of vertical angle alpha 1. Now we have to shift this theodolite to the second station R. Otherwise, we can keep another theodolite at R. R dash is the vertical projection of R. We need to measure the horizontal distance between P and R. Let us denote the distance as D. Now from the station R, we have to focus the top of the tower. We need to find the reading of vertical angle alpha 2. In the benchmark, we have to keep a leveling staff, and from the stations R and P, we have to take the staff reading. Both of the readings will be same because both of the instrument axes are in the same level. Let us keep the staff reading as S. We know that both of the instrument axes are at the same level. Because of that, we have got the same staff reading and we have denoted that as S. Let us take this triangle. In this triangle, let us apply tan theta formula. We know that tan theta is equal to opposite side by adjacent side. Here the opposite side is h and the adjacent side is d. So tan alpha 1 will be equal to h upon d. We can take d on the other side, so it will come in the numerator. In this way, we can make this expression. Now let us take this big triangle. In this triangle, let us apply tan theta formula. Tan alpha 2 will be equal to the opposite side h upon the adjacent side, which is d plus d. So h will be d plus d tan alpha 2. For h, we have got two relations. We can equate both of them. Let us multiply this with tan alpha 2 so that we will get these two terms. Let us take d tan alpha 2 on the other side, so it will come as negative. From these two, we can take d outside and we can take this on the other side, so it will come in the denominator. This is the formula to find the distance d. In this one, we can apply the formula of d. In this way, we will get this expression. To find the reduced level of Q, we need to add the reduced level at the benchmark, the staff reading, and the height h. Now let us see a problem. Using the following observations, find the reduced level of the top of the tower. The instrument stations are given as A and B. The readings on the benchmark are given as 1.63 meter and 1.63 meter, both of them having the same value. That means that the instrument axes are in the same level. Both of the angle of elevations are given. The reduced level of the benchmark is 200 meter and the horizontal distance of AB is given as 50 meter. Using the data, we can draw the figure. Unless it is mentioned in the question, we have to go in the alphabetical order. A should be nearest one to the tower and B should be next to A. Let us mark the vertical angle. At A it is 16 degree 15 minutes and at B it is 14 degree 30 minutes. The staff reading from both of the stations is 1.63 meter. The reduced level at the benchmark is given as 200 meter. The distance between A and B is 50 meter. We need to find D and H. Using this formula, we can find D. Small d is 50. This is alpha 2 and this is alpha 1. For D, we will get 393.564 meter. Then we can take this triangle. In this triangle, we can use the tan theta formula. Tan 16 degree 15 minutes is equal to the opposite side h upon the adjacent side. In this way, for h, we will get 114.713 meter. Otherwise, we can use this formula and get h directly. Now we need to find the reduced level of the top of the tower. We need to add the reduced level at the benchmark, the staff reading, and the height h. When we do that, we will get 316.343 meter. Now we are going to end this session. Thank you for watching this video.